All right, I want to just get started today with the good thing. There is no limit to, and go ahead and fill that out in your daily engagement if you're in Connect or on your warm-ups if you're here with me. The first problem I want to do with you on your guided notes is graph the following where k is a positive number, and then tell me what value k would have to be. So in order to graph this, remember h of x is just the code word for y. So there are two equations here for this piecewise function. Y equals k for x less than or equal to 0. And so this is my breakpoint here. Y equals 0. I'm sorry, x equals 0. So let me go ahead and put in my breakpoint. And what that means is something different is happening on the left side versus the right side of this graph. So let me go ahead and draw a line here, okay, at x equals 0. On the left side of this graph, I'm going to use y equals k. All right, so remember, k is some sort of positive number. So k could be 1/2, k could be 2, k could be 5, whatever it is, that's what y equals. So what I know about this graph, what it looks like, is it's just a horizontal line at k, wherever k is. Okay, and it's actually, is it a solid circle or is it an open circle at x equals 0, at the domain x equals 0? Well, this equal sign tells me that it's a solid circle. So I know my picture looks like that on the left side of 0. On the right side of 0, my picture looks like ex plus 1. All right, this is another parent function that you need to have memorized. You need to know y equals 1 over x, y equals 1 over x squared. Of course, you need to know how plus or minus looks like. And you also need to know what y equals e to the x looks like. Y equals e to the x looks like this blue line right here. And then we're going to add 1 to it. And what does adding 1 do? It shifts this function up by 1, right? So if you plug in 0 here, you'll get y equals 1. So that's this point here. Now I'm going to shift it up 1. So now I'm going to be here. At 0, I won't be at 1 anymore. I'll be at 2. And there's an equation, there's a point here, 1e1. So this next point, right, is going to be, I'm going to shift it up 1. So somewhere there, 1 comma e plus 1, right? And so my new function looks something like this, right? Everything is shifted up by 1. So this is my y equals e to the x plus 1. But I'm only interested in this right side where x is greater than 0. So what I'm going to do is I'm going to plot this 0, 2 here. And I'm going to go ahead and sketch in what y equals e to the x plus 1 looks like to the right of x equals 0. Now the question is, what would the value of k have to be for this function to be continuous, which means this function is going to connect, this line is going to connect with this line, right? And some of you might see it very easily, but what it means is that this thing right here must come down and be right here, right, for this to connect. So to make this thing continuous, what does the value of k have to be? Right, k must be equal to 2, right? Because this point here was at 0, 2 for this function to be continuous. All right, let's go to another question, or let's go to limits actually is what we're going to talk about today. And so we're going to talk about limits. And there are 4 ways that College Board wants us to teach limits, okay? Verbally, graphically, algebraically, and numerically. Today we're going to talk about verbally, numerically, and graphically, okay? Algebraically we'll save for tomorrow. So finding limits numerically first, okay? Let's look at this. This is actually verbally. Limits intuitively is the idea of getting close to a number. So as x gets closer and closer and closer to some number, y gets closer and closer to another number. And that number that y gets closer and closer to is called the limit. Okay, so the limit is always a y answer. Just FYI, on your homework, if your y answer is ever 0 over 0, this actually is not an answer. It's called indeterminate. And what that means is that there may be an answer, there may not be, but the method that you're using doesn't work. You'll have to use another method. All right, so just be careful about that. All right, let's look at limits numerically first. If I wanted to find the limit to this problem, and I wanted to find the limit using a numerical method, what I do is I understand what this is saying. This is saying if I graph this function, okay, and I don't know what this function looks like, okay, but if I graph this function and at x equals -3, okay, the question is, the x gets closer and closer to -3 from the left and from the right, okay, what is the y value? Okay, this y value right here. What is the y value that that y is approaching when x gets closer and closer to -3? Okay, that's the question. All right, so it seems practical that I should just plug in -3 right there, right? Because that would give me the y value. So let me plug in -3 for x, -3 for x, and what I'll get is the square root of 1 minus 1 over 0, okay, is equal to 0 over 0. Remember what we said. 0 over 0 means this answer is indeterminate. 0 over 0 is not equal to 0, all right? It just means the method that I used, I have to use something else. All right, so I know that I can't just plug in -3. So instead of plugging in -3, I'm going to use the numerical method. And what I'm going to do is I'm going to get closer and closer and closer to -3 from the left of -3 on the number line. And I'm going to get closer and closer to -3 from the right of -3 on the number line. And I want you to think about the number line. Does this look like a good number line? Okay, if -3 is here, okay, is -2.999 on its right, and then -2.99 next to it, and then -2.90 next to it. Is that right? Right? Because this should be approaching 0 as I go to the right. And on the left side, is this -3.001, and then -3.01, and then finally -3.1. Okay, am I getting closer and closer, or am I getting more and more negative as I go this way? And yes, I am. So what I do is I go into my calculator. I'm going to switch to my calculator now. And I'm going to put these numbers into my calculator. Oops. Okay, I'm going to put these numbers into my calculator. So first what I do is hit y equals and put this function into y equals. Okay, so this is going to be, I'm going to open up the parentheses, the square root of x plus 4. All right, then I want to subtract 1, and I want to divide all of it by x plus 3. So let me actually insert a parentheses here. Second insert parentheses, come over here and insert a parentheses. And I'm going to divide all of that by parentheses x plus 3. All right. I can graph it if I want to see what it looks like. So it looks something like that. But what I really want to do is as x gets closer and closer to -3, I want to observe what y value the y is approaching to right here. And the calculator, it's almost impossible to see that. So what I'm going to do is I'm going to go to table, okay, and that'll give me my numbers here. But I don't want to plug in -1 and 1 for my numbers, okay? I want to know what happens at -3, but these numbers are too big. I want to plug in -3.1. So what you do is you hit second table set and change your independent from auto to ask. So I'm going to set this to -3. I want it to start at -3. I'm going to come down here and change this to ask, then hit enter, and it actually has moved to ask when you hit enter. And then I'm going to hit second table. Okay, and what this does is it lets me put in numbers. So I'm going to put in negative 3.1, enter, and I can see that answer is 0.51317. And then I'm going to put in negative 3.01, and that answer is 0.50126. And you can see what I'm doing. Negative 3.001, that's 0.50013. And let me go to the right of negative 3. If I go to the right of negative 3, I'll put in negative 2.999, and the table will have 0.49988. If I put in negative 2.99, I'll have 0.49876, and negative 2.9 gives me 0.48809. All right, so what I want to do is I want to observe these numbers and say, as x gets closer and closer and closer to negative 3, okay, what are my y values getting close to? My y values are getting closer and closer, do you see, to 0.5. They're getting closer and closer to 0.5. So I'm kind of guessing here. I think it's 0.5. So I'm going to say the limit of this function, of this f of x, as x approaches negative 3, okay, is 0.5. And I can go through decimals to make it, I guess, 4 decimals to make it kind of accurate, 5 decimal places to kind of make it accurate. But I mean, I'm just kind of guessing here. I'm saying it looks like it's approaching 0.5. And tomorrow we'll talk about a problem like this algebraically, and we can actually verify if it really is 0.5 or not. All right? That's how you find limits numerically. Let's do another problem. Here's a problem, okay? If I graph this, okay, what I'm saying is if I graph this function, okay, as x gets closer and closer to 0, what does y, what does this function, what does f of x equals sine of 4x over x get closer to? Okay, and that's verbally how we're interpreting limits. Okay, and the answer to this question is the answer to this limit. All right, so let's do this problem numerically. Okay, of course, if I graph this function, again, I don't know what it looks like, but let's just graph it. If I graph it, what it's saying is when x is equal to 0, okay, as x gets closer and closer to 0 on both sides, what is this y value? How do I find it? Well, doesn't it make a lot of sense? I would just plug in 0. Well, let me go ahead and plug in 0. Plug in 0 there and plug in 0 here. What I'll get is a sine of 0 over 0, okay, which is what we call indeterminate. Indeterminate. And indeterminate, okay, is not the same thing as undefined. Indeterminate means I don't know if there's an answer, but the way I did it, that's not how I do it. I need to do it some other way, all right? So the way we're going to do it is we're going to use the numerical method of limits. And so what I'm doing is I need to get closer and closer to 0. So let's think about this. As x approaches 0, so let me just put 0 here on the number line. Okay, what's a good number to the right of x? Well, maybe 0.001. And then what if I moved over further from 0.001? Maybe 0.01, maybe 0.1, something like that. And what about if I were to the left of 0? Wouldn't that be negative 0.001? And then maybe a little bit bigger than that would be negative 0.01. A little bit bigger than that might be negative 0.1. Okay, so what I'm going to do is I'm going to get a calculator. I'm going to put these numbers in, and I'm going to see what the y value approaches when this happens. So let me get my calculator out. Okay, on my y equals, I'm going to have to change this problem. The function now is sine of 4x divided by x. Okay, let me just go ahead and graph it and see what it looks like. Okay, it looks something like this, all right? And what I want to know is when x is 0, what is this value here? And I tried to plug it in, but remember I got 0 over 0, so I need to use some other method. All right, so I'm going to go to my second table set. Again, right here I want to put this on 0 because I want it to be close to 0. And that's a 0 right here, and this limit as x goes to 0 that I'm getting that 0 from. I want to make sure my independent changes from auto ask, which it already is. Then I'm going to hit second table. And I don't know if there's a way to clear this table. There probably is. I just don't know how to do it. I'm just going to punch numbers in here. Maybe I can hit delete. Not sure how to clear this table. All right, so let me go ahead and enter negative 0.1. What I get is 3.8942. So I'll plug that in, 3.8942. Let me plug in negative 0.01, so negative 0.01. And what I'll get is 3.9989, so 3.9989. What if I plug in negative 0.001? Getting closer and closer to 0. I get negative 2.999. Well, that's interesting. Is that right? No, I don't. I get 4. I'm reading this wrong. When I plug in negative 0.001, I get 4 right there. All right, and then let's go to keep filling out the table. What if I plug in 0.001? I'll get 4. And what if I plug in 0.01? I'll get 3.9989. And what if I plug in 0.1? I'll get 3.8942. So you can see as x approaches 0 from the left and from the right, okay, my y value is approaching, has approached the same number for there to be a limit. My y value is approaching 4. And so that is the answer using numerical methods for this limit. The answer is 4. Okay, so again, limits is the idea of getting closer and closer to some number. So as x gets closer and closer to some number, y is going to get closer and closer to some other number. Now, some problems don't have limits, okay, and we'll talk about that. But for the problems where you come from the left of x and you come from the right of x and you get the same number, that's when you do have a limit, okay? And so that's the big idea. The big idea is if you're coming from the right of some numbers, so the limit of g as x approaches c from the right, that's what this plus sign means, and the limit of g as x approaches c from the left. If both of those are the same, if they're equal to each other, then you're going to have a limit. Okay, so for example, our last problem, the limit was 4. Okay, and that would be the limit of g as x just approaches c. Okay, if these two numbers are different, okay, if you got 4 here and 2 here, then what you would have is no limit for this problem. All right, but we did have a limit on the last problem that we did. Okay, and so again, this is the verbal definition of limits. You need to make sure you can say this. This notation here, you need to be able to write this notation correctly. This is as f of x gets closer and closer, as x approaches c from the left and as x approaches c from the right, okay, f of x will approach the same number, L or 4 or 5 or whatever that number is. Okay, and that's what it says in your notes. All right, then I want to change to finding limits graphically. Okay, and I think finding limits graphically is a little bit easier than numerically, but sometimes students also get confused. So what I'm going to do is I'm going to sketch this graph and show you how this works. All right, so this is a piecewise function. Okay, the breakpoint is what? It's at 2, so let me go ahead and graph 2, okay? That means this graph acts differently from the left of 2 and from the right of 2, okay? So let me go ahead and see if I can draw a line here. Okay, so on the left of 2, okay, Well, actually, it's not the left 2 and the right 2. When x is not 2, it acts differently from when x is equal to 2. So when x is not 2, so when you're not on this line, your equation is x squared plus 1. Okay, so let's think about this. What I do is I always plot this at the breakpoint. So I'm going to put the breakpoint in here. That would be 2 squared plus 1, which is 5. So at 2, 1, 2, 3, 4, 5. Okay, I'm going to plot this point 2, 5. It's an open circle because it's actually not equal at 2. All right, and then let's see, x is not equal to, okay, so let me plug in some points over here. When x is equal to 1, okay, that means x is not equal to 2. This would be 1 squared plus 1. So when x is equal to 1, I'll have 2 here, but this is a closed circle. When x is equal to 0, I'll have 0 squared plus 1 for y. So that means this is 1. When x is equal to negative 1, I'll have negative 1 squared plus 1. So that's equal to 2. So right here. And if x is equal to, let's say, negative 2, I'll get negative 2 squared plus 1, which is 5. So that's up here. And I know what this function looks like. It's x squared plus 1, right? So it's an x squared graph shifted up 1. So I'm going to go ahead and sketch this. Okay, the only thing is you have to be careful. It's true to the left of this and to the right of the 2, but it's not true at the 2. Okay, what is y equal to when x is equal to 2? When x is equal to 2, y is equal to 3. So what I do is I put another point right here at 3. So this is 2, 3. And this is my piecewise function. I mean, what I really drew, if you want to see it a little bit clearer, is something that looks like this. Okay, that is my piecewise function here. All right, and so the question is, so the question is, what is the limit of f of x as x approaches 2? Well, let's think about this. This is 2 right here, okay? And as x gets closer and closer and closer to 2 from the left, what y value am I approaching? 5, right? And as x gets closer and closer to 2 from the right, so it's traced from the right, trace this function coming towards 2, what y value am I approaching? 5. So the limit as x approaches 2 from the left is equal to 5. And the limit as x approaches 2 from the right of f of x is equal to 5. So therefore, the limit as x approaches 2 of f of x is actually equal to 5. Now, why isn't it equal to 3? Well, the limit's not equal to 3, but if I asked you what's f at 2, you would say that that is 3. Okay, so these two things can be confusing. Okay, but limit is not the same thing as plugging in. If I actually plugged in, I would get 3 as the answer. But if I'm taking the limit, I would actually get this. This is my answer here. Okay, the value right here, the y value here at this hole. Okay. Let's do this problem right here. We're going to sketch this and we're going to try to find the limit. So let me sketch this. Okay. There's a breakpoint at negative 3. So let me put that in, the breakpoint at negative 3. And let's see. Let me plug in negative 3. If I plugged in negative 3, what I get is 0 over 0. Okay, so that means I can't find the limit just by plugging in. It's not that easy. Okay, so let me see if I can graph this. It's not really a piecewise function. At negative 3, I don't have anything, but let's say at negative 4. If I plugged in negative 4, this is x equals negative 4. What I'll get is the absolute value of negative 1 over negative 1, Well, this is going to be positive, so this is -1. So if I plug in -4, what I get is -1 right here. What if I plug in -5? If I plug in -5, okay, what I'll get is 2 over -2, which is -1. So if I plug in -5, I'll get -1. What if I plug in -4.5? So -4.5 plus 3 over this absolute value of -4.5 plus 3, all right? That's going to give me 1.5 on the top and -1.5 on the bottom. So that's still -1. So if I plugged in -4.5, that's -1. What if I plugged in -3.5? -3.5 plus 3 over -3.5 plus 3. That's going to give me 0.5 on the top. It's always positive on the top. And -0.5 on the bottom, which will give me -1. So -1. So basically, this function is going to, if I connect it, it's really just -1. But right at -3, it's an open circle. Okay. What happens if I plug in numbers bigger than -3? So let me plug in -2. So if I plugged in -2 into this function, what would I get? I would get 1. So at -2, I would get 1. All right, what if I plugged in -1? This will give me 2 over 2, which is 1. So I would get 1. What if I plugged in 0? If I plugged in 0, I would get 1. So it turns out this is always going to be 1 here, all the way to -3, and there'll be an open circle there because you can't plug in -3. So this is the graph that I'm looking at here. If I were to redraw it just to make sure we understand what the graph looks like, at -3, you'll have something that looks like that, and that is our graph, basically. And so the question is, what is the limit as x approaches -3? Okay, as x approaches -3, what's the limit? Well, as you approach -3 from the left, what y value are you approaching here? -1, right? So the limit as x approaches -3 from the left of this function, okay, is equal to -1. What if I approach this function at -3 from the right? What would I get? Well, from the right, what y value am I approaching when I get to -3? 1, right? Well, this is -1 and this is +1, okay? So this limit does not exist, okay? The limit only exists if the y value that it's approaching is equal from the left and from the right, of the x value from the left and from the right, okay? This right here is a discontinuity in the piecewise function. This is called a jump discontinuity, okay? You can see it jumps. The value jumps from -1 and it jumps to 1, okay? All right, so that answer was D and E. Let's skip the last page and let's look at some more limits graphically. Okay, so if I had a graph like this, what is f of 1? So I look at the x value at 1, okay, and what is the y value? Okay, I can see that there is no y value. There's no dot anywhere. So this is D and E, okay? What if I approached 1 from the left? What would be the y value? Okay, so here's the 1. Okay, I'm going to approach it from the left. So here's my function. I'm approaching from the left. What y value am I approaching as I get to 1? That should be -1. All right. What y value am I approaching as I approach +1 from the right? Okay. Be careful. This is not -1. Okay. This is approaching 1 from the left. Okay. Now I'm approaching 1 from the right. All right. So here's my function. Let's get real close to 1. As I approach it from the right, what y value am I approaching? -1. If these two are the same, if approaching from the left and approaching from the right give you the same answer, then when you drop the left and right, you have a limit. Okay, so the limit of f of x as x approaches 1 is equal to -1. Let's look at this problem here. Now I'm going to approach -3 from the right. So here's my -3. If I approach it from the right, now don't start all the way over here. This is going to confuse you. You want to start kind of close to -3. And as you approach it from the right, what y value am I approaching? -infinity, right? Yeah, -infinity. And if you approach -3 from the left, so let me kind of get close to -3. If I approach it from the left, what y value am I approaching? +infinity. Okay, so here's a question. Is -infinity and +infinity the same? No. So the limit of f of x as x approaches -3 is actually equal to dne. Okay. Another thing I want to tell you is this actually, there's another answer to this one. You can actually say this is dne if you want, because what you're saying is if you get smaller and smaller and smaller and smaller, the limit doesn't exist. dne does not exist. And if the limit, well, this is saying the limit is decreasing without bound. And when the limit decreases without bound, it doesn't exist. And here you're saying the limit is increasing without bound. And if it increases without bound, the limit doesn't exist. Okay. Infinity is not a number. Okay, the limit doesn't exist. Okay, and if you have 2 doesn't exist, then this is also doesn't exist. Okay, it's incorrect to say that this is. I mean, that's not correct. Okay, but this has 2 answers. This has 2 answers. On your test, I'll expect you, I think, to give me this answer if there is an answer for negative or positive infinity. If there's not, then you can say does not exist. All right. What about if it's not a limit problem? What if I just want to know at -3 what is the y value? So I can come up here at -3, and do you see there's a vertical asymptote there? Okay, that means there's no function value at -3. So this is also does not exist. Let's look at this same graph here. I'm going to look at some other limits. What happens is as x goes to -infinity, what is the y value? So let's go, remember x to -infinity is way out here, okay? As I approach this and I follow it, what y value is it approaching? Yeah, you can kind of assume that it's approaching 0, just the way it's being drawn, okay? What about as x approaches positive infinity? As x gets bigger and bigger and bigger, way out here, way out here, okay? What is the y value here approaching? Okay, you can see these little dots here. This is actually a horizontal asymptote here. So this is saying -1. All right, okay. What is f at 0? So this isn't a limit problem, just f of 0. So at 0, what is the functional value at 0? Okay, it's this one right here. Do you see it? There's a dot right there. So this answer is -4. All right, what is the limit of f of x as x approaches 0 from the left? So here's x equals 0. Okay, get really close to it on the function. Here it is right here. As you approach 0 from the left, what y value are you approaching here? It looks like about -1/2. You can just approximate it. Now, as you approach 0 from the right, what y value are you approaching? -4. Okay, so here's a question. What is the limit of f of x as x approaches 0? So for there to be a limit, for this to have an answer, okay, the limit of f of x as x is approaching 0 from the left must be the same as the limit of f of x as x approaches 0 from the right. And do you see these two numbers are different? Okay, and since they're different, then this answer does not exist. And we kind of talked about this. You see, there's a jump here. Okay, x goes to negative 1/2, and then it jumps to negative 4 here. There's a jump discontinuity here, and that jump discontinuity makes there to be no limit. Okay, now you can have a hole discontinuity. There's still limits at holes, but there are no limits at jumps. Okay, so let's look at this right here, the limit as x approaches 5 from the right. So here's my 5 right here. X is 5. I'm going to approach it from the right, kind of get close to the 5 here, follow the function, get closer and closer to 5, and what I get is positive infinity here. That's the y value as x approaches positive infinity. Make sure you're reading off the y value here. The limit problems are always a y value answer. All right, what's the limit of f of x as x approaches 5 from the left? I can see that answer is positive infinity. So what is the answer as the limit of f of x as x approaches 5? Well, if these two are the same, then this is also the same. Okay. Now make sure you understand that the infinity is not a number. All right. So it's for limits. It's the same thing as the limit doesn't exist, because as you increase without bound, you never have a limit, right? And this also could be called DNE. And of course, this also could be called DNE. So make sure you understand that all of these are answers to this problem. On the test, I will have you write positive infinity because it's a little more accurate than does not exist. But if it were a multiple choice, and I accepted does not exist, you could also put does not exist. All right, let's do some more of these problems. Okay, let's look at this graph. What's the limit as x approaches negative infinity? You should try doing it on your own. Okay, and then check with me here. You can pause this video and check with me here, see if you got the answers right. As x approaches negative infinity, okay, so all the way over here, here's my x approaching negative infinity. Let me follow this along. What is my y value approaching? And then also as x approaches positive infinity, so right here, as x gets bigger and bigger and bigger, what y value am I approaching? Okay. All right. What's the limit of f of x as x approaches negative 1 from the right? So let me find negative 1. Here it is. As I approach it from the right, what y value am I approaching? Now be careful. The answer is not 2 because we're talking about limits here. Okay, we're just saying what y value getting closer and closer to. All right, and then from the left, what y value are you getting closer and closer to? Okay, and then are these the same? If they're the same, then when you're asking for the limit of f of x as x approaches negative 1, you just copy the same number down. If they are different, then this answer would be DNE. Okay, now what's f at negative 1? Now this is not a limit problem. This is just saying when you're at negative 1, what's your y value? Your y value here is negative 2. Okay, so make sure you understand that. The plot is at negative 2. Okay, but the limit, the value that y is approaching from the left and the right is actually negative 1. Okay, what's the limit of f of x as x approaches 2 from the right? So here's my number 2. Okay, get really close to number 2 on the right. What y value am I approaching? 0. Okay, what about from 3 from the left? As x approaches, here's your 3. From the left, what y value am I approaching? That answer is 2. Okay, what about the limit of f of x as x approaches 1 from the right? So here's my 1. I need to get to the right of 1. What y value am I approaching? 2. Okay, what about to the left of 1? Okay, as I get close to the one on the left, what y value am I approaching? 1. Okay, so if this is 2 and this is 1, what's the limit of f of x as x approaches 1? If I drop these right hand and left hand, they need to be the same to have an answer. And since they're not the same, the answer is it doesn't exist. And you can see why it doesn't exist, because there's a jump discontinuity here. Okay, we've talked about that. But the limit does exist here because this is a hole. Limits do exist at holes, but they don't exist at jump continuities. All right, what's the value of y when x is 1? This is not a limit problem. Okay, and I can see that that answer is just 1. All right, what's the limit of f of x as x approaches 0? So remember, they've dropped the plus and negative here. Okay, so I need to go look at my x equals 0 and say 0 from the right and 0 from the left. Am I approaching the same y value? Yes, I am. And so that answer, the y value is 0. Okay, what about as x approaches 11 of f of x? Okay, so 11 is way out here. What's the y value over here when x is 11? Okay, that's 2. Okay, so let's look at this problem. This one's a little bit tougher. There's two graphs here. There's an f graph and a g graph. And first I want the limit of f of x as x approaches 1 from the left. So if I approach 1 from the left, I can see that answer is 2. If I approach 1 from the right, I can see that that y value is 2. So if those two are the same, then when I drop the plus and negatives, then this limit is 2. What's f of 1? So this is not a limit problem. This is just saying what's the y value right there? Well, that answer is 2. Let me do this these g limits over here. On the g function, as x approaches 1 from the left, what y value am I approaching? 2. What about 1 from the right? What y value am I approaching? 2. Okay, if these two are the same, then the limit as x approaches 1 is 2. But here's a trick question. What's g of 1? It's not a limit problem. G of 1 is just 1. All right. So in limit properties, when you have the limit of f of g of x, this is a composite function, as x approaches 1, it gets a little bit tougher. Now what a lot of students would do is they'll plug in this 1 right here, and they'll say this is g of 1. And they know that g of 1 is 1, and they'll put 1 in here so that they'll say this is the limit as x approaches 1 of f at 1. And that's actually incorrect. I'll tell you why. This f of 1 here, so then you find out what f of 1 is. Well, f of 1, we've already done it, right? It's right here is 2. Okay, that is incorrect. The reason it's incorrect is because the limit actually is a limit of g of x too. It's not just a limit of f of x, but it's a limit of g of x. Okay, so the right way to do this is to say this is the limit, this is equal to f of the limit as x approaches 1 of g of x, okay, like that. This is the right way to do this problem. So the first thing you would do is you would find the limit of g of x as x approaches 1, okay? And now that answer is not 1, okay, but 2. How do I know? Because right here, okay, the limit of g of x as x approaches 1, that's 2. So this answer is not f of 1, but it's f of 2. And then I come over here and I say, okay, what is f of 2? That is 3. And that is the answer to this problem. Okay, this up here was done incorrectly. All right. This problem's a little bit difficult, but I think we can do it. All right. Let's look at this problem. The limit of f of x as x approaches 1 from the left. Okay, so I'm going to go 1 from the left here. This is a limit problem. Okay, I'm going to ignore this up here, okay, because this is not 1 from the left. This is not this doesn't apply when I'm looking at limits. Okay, so the answer here is going to be 0. 1 from the right, the answer is also going to be 0. Then if these two are the same, coming from the right and the left are the same, this is 0. And then finally the question is, what's f of 1? That's going to be 2. All right. And then what's the limit of g of x, okay, as x approaches 2 from the left? All right, so 2 from the left, this is my value for g. Okay, my g value is 1. What about when I approach 2 from the right? if I approach 2 from the right, the y value now is what? It's -1. What if I approach just 2? Okay, then that answer does not exist because there's a jump discontinuity here. All right, and then finally, g of 2. What would g of 2 be? Well, g of 2 is actually where there's a functional value, and that answer will be 1. Okay? All right, these are properties of limits. You need to look over them, make sure you understand them. I think they might be on your next notes, but basically for your homework, you'll be using this property, the sum rule property, and the product rule property, and the composite function rule property, which is what we did on this homework problem over here, the composite rule property. All right, let's look at problem 6. This one's a little bit more difficult. A lot of times what students want to do is just plug in here, and sometimes this works and sometimes it doesn't. If you plug in and use limit properties just to multiply these together, what you'll get is f of 2 is equal to -1.3. G of 1 is equal to 1. Okay, you multiply these together and you'll get -1.3. But remember, the real way to do it is actually to take this function, find when it's approaching 1 from the left and 1 from the right. And if these two answers are the same, then that's how you get this answer, okay? So let me just go from the left here, all right? So, if it were a continuous function, you really could just plug in here and you wouldn't have a problem. The problem is you've got a lot of discontinuities here, okay? And that could give you the wrong answer by just plugging in. All right, so let's go 1 from the left. If I went 1 from the left, that would be like 0.99, right? So I'm going to be like 0.99 here, and this would be like 0.99 here, okay? So what it's saying is if you had f approaching 2 from the left, right, because it's about 1.99 times g of 0.99, right? So we're looking at f approaching 1.99. So here's 1.99. As f approaches 2 from the left, it's really saying, what's my y value? Well, that's -1.3. What about g approaching, this is really 1 from the left, right? So because 0.99 is here. So when g is approaching 1 from the left, about 1.99, what's my y value? That's 1. If I multiply together, I do get -1.3, which looks good so far because it's the same as what I got above. But I do need to check 1 coming from the right. Well, 1 coming from the right is like 1.01, right, or 1.001. So if I put in 1.01 here and 1.01 here, then what I can see is this would be f of 2.01 times g of 1.01. And so what I'm saying is I'm saying 2 coming from the right, right, because it's a little bigger than 2. So f of 2 coming, 2.01 coming from the right here, it's approaching -1.3, okay? And g 1.01, so I'm saying g 1.01 is here, okay? So as I approach 1.1 from, this is from the right of 1, okay? So I'm approaching 1 from the right. My value here is 1, so I get -1.3. So this is correct. These two numbers are the same, okay? So therefore, the limit of this function, or this expression as x goes to 1 is actually also equal to -1.3. I'm not sure if this method was right, but it did give us the right answer. When you plug in 1 here and you plug in 1 here, what you get is a limit as x approaches, f at 1 times the limit as x approaches 1, well, I don't know, x approaches, you get g of 2 here, kind of. And when you look at this, it's really hard to figure out because over here, the limit as x approaches 1 is 0. That's pretty easy to figure out. But over here, when you plug in 2, when you plug in here 2 for your limit, okay, what is your limit? Is your limit this number? Is it this number? Is it D and E? I mean, your limit doesn't exist because it's a jump here, right? Approaching the left and the right of 2, you get doesn't exist. So what is 0 times D and E? This is actually an indeterminate form. You don't know what the answer is. You need to use another method. Okay, some people might say that this is 0. Some people might say that this is D and E. All right, but what it is you have to break it up into -1 and 1 to get the answer. So for example, approaching 1 from the left might be like 0.999, right? This might be like 0.999. So what I'm doing is f approaching 1 from the left, what is that answer? So here's approaching 1 from the left, that answer is 0. And I multiply it by g approaching 1.999. So really approaching 2 from the left. So this is g approaching 2. I'm looking at 1.999. So that's kind of like right here from the left. And that's approaching 1. So this answer is 0. If I do this problem down here and I plug in 1 from the right, okay, that's like plugging in 1.01, right? So this would be like 1.01. So I'm really doing is taking the limit as f approaches 1 from the right, okay, so that's going to be 0 times the limit as g approaches 2, but it's from the right because this is like 2.01, right? So that's kind of like coming from the right. 2.01 is over here. So the limit of g of 2.01 coming from the right of 2 is actually 1, -1. So this answer is 0. Since this is 0 and this is 0, then this answer is 0 also. Like we wouldn't use this method. We'd actually use this method, which is a more accurate way to do this problem. All right. This is very difficult. I just want to make sure you know how to do it. Wouldn't stress about it if you have problems with it. You may have this on your test. I'm not sure, but if you do, it would just be one problem. And so I wouldn't stress about it if you don't completely understand that. Okay, let's look at when behaviors of a limit doesn't exist. We talked about when they approach a different number from the left and right side, kind of like this. It's called a jump discontinuity, and limits don't exist when you have jumps, okay? Also, when you have a crazy oscillation, we talked about that. If you had the limit as x approaches 0 of a function like this, or even the cosine function, something like this, if you had 1 over x, and even if you had a coefficient, it wouldn't matter. What happens is, as x approaches 0, the y value can't get decided. It goes crazy, and that's called an oscillating discontinuity, or I call it a crazy oscillation. Okay, and then finally, when you have a vertical asymptote, okay, this is called an infinite discontinuity. And if you have a vertical asymptote, the limit won't exist either. So there are actually 3 times when there is no limit, okay? And that is when there's a jump discontinuity, an oscillating discontinuity, an infinite discontinuity, or a jump, or a crazy oscillation, or a vertical asymptote. And the way I remember that is there is no limit to my jump, oscillating, and infinite. There is no limit to my joy. And that's how you will remember when there is no limit. Now remember, there are limits at poles though, okay? There are just no limits at jump, oscillating discontinuities, or crazy oscillations, and vertical asymptotes, okay? So there is no limit to my joy. You need to remember that, and that will help you to remember when there's a limit and when there's not. All right, good luck on your homework. Hope that helped.